Okay, I'm going to talk about permanent connections, and this is some of the background for that. So permanent connections is, welded or riveted, basically of one form or another. So we're going to start by talking about some rivets, blind rivets. You might have heard them called pop rivets, formed rivets, which can be hot or cold, before we start to talk about the various welding processes. So if we look at blind rivets, what that really means is there's no access to the back of the joint. And as such, what you need to do is grab this stem, which will pull through the body of the rivet. And in doing so, we'll blow that out, flare that out, until you get to a limiting tension where through the shank of it, the head will fall or break away, basically, and you'll pull the pin clear of the joint. There's a number of different styles of rivets, as you can see here on the screen. To our left, we've sort of got a regular sort of shaped rivet. You can get ones that got a much bigger head on them, wide heads, as well as tapered for countersink type riveting. This guy here is just an anodized aluminium. If you walk into your local Bunnings, you'll find them in all sorts of different colours. They come in, obviously, different materials. So this guy down here is a copper rivet. Most of these are probably aluminium, but you can get monel, as well as some other stainless steel rivets, all different sorts. Most of these rivets, well, actually, no, not most of these ones. I'll say these guys are what we would call an open rivet, because once the shank breaks off, there's a little bit that's retaining this, but that can actually fall out, and you've got a hole that goes straight through it. If I look at this guy, the bottom end of this through here is closed. So when the shank breaks, it's left as a sealed or a closed rivet. These two guys here split apart, and they're designed for holding soft materials, if you like. So these are a couple of different split type rivets. The others are all just variants of the same sort of thing, and they come in different grip lengths as well as all sorts of other stuff. So nothing too complicated with those. And you just use a little handgun to set these things into the position. If we go looking at solid rivets, now I've got a couple of different things here. These here are called hammer drive rivets. Basically, you drill a hole. These are only fairly small, and you drive these in with a punch, and they're, if you like, a secure rivet that you can't easily pull out, if you like. But it's still one-sided. You don't need access to the underside. If you look at what's more normal for a solid rivet, now this little graphic here sort of illustrates that, in this case, it's sort of indicating a hot rivet, but you've got a die at the bottom which is held firm. Now that might be with a big hammer underneath it, and then the moving die at the top, tries to form the head of that into the right sort of shape. Then as it cools down, it's going to pull that joint tightly together. If you look at, where you'll most often see a rivet or a solid rivet, most of you will have a pair of jeans somewhere, and they'll have a rivet in the corner of the pockets, for example, and this is just a high stress area. I think part of it's aesthetics these days more than anything, but originally jeans had rivets in them for this particular reason, was for the extra strength it gave. If you're out and about, you'll see lots of old structures that have an awful lot of rivets on it. And this is in part because welding, certainly for sight welds, wasn't really that advanced. So you would often set up a little forge at the site. You would heat your rivet up until it was this lovely warm temperature here. And then the guy operating the forge would pick it up in a pair of tongs and throw it, literally, to the person who had a catcher's glove. They would catch it, stick it in the appropriate hole, and one person would hold, again, the fixed anvil, while somebody else belted the moving anvil to form the shape of the head, all before it got too cold. And they used all sorts of different materials to give different working lives, etc. The image I've got over here just happens to be the Titanic, being one of the most famous ones for it. But you can see rows and rows and rows of holes all along here, which are to take rivets. And you can see this big frame here, that's the anvil that is setting those rivets. All right, so it's invariably got some sort of a pneumatic hammer on the backside or something, or a hydraulic hammer, that they dropped this down, got the rivet in place and hit it with this very large hammer. It's one of those ongoing points of contention about why the Titanic sank, and part of one of their arguments is that the rivets they were able to use along this main section here were of a higher grade because they had the big mechanical hammer. Where they got down into the pointy bit of the boat, they didn't have room to get the mechanical hammer in, so they needed to use a softer rivet that was able to be hand swaged. So, yeah, bit of trivia. One of the interesting things, obviously, with rivets, if I look here, if my two holes aren't perfectly aligned, then I drop my rivet through it, which is going to be somewhat undersized anyway. When I start bashing that, then it will expand out and fill that cavity. So you actually, if it's done properly, by the time that's domed over, your rivet should have fully filled the cavity and dealt with any misalignment in your holes, which you can imagine with all the holes along the side of that Titanic, they're not going to be micron accurate. So here's where you might use rivets. The left side's obviously a monocoque chassis of a race car. The right is an old aircraft. And you think, gee, there's a lot of work in putting all those rivets in. And yes, you're right. Why wouldn't I weld it? Well, we're going to talk about welding in a minute. And one of the reasons is wherever you lay a bead of weld, you upset the material properties. And you set the properties back to a less tempered condition. So by riveting all of these, you know that the base metal properties remain identical, which is really important at times. Okay, if we look at welding,